A big thank you to all my patrons who support the Engineered Mind podcast. Hi and welcome to the Engineered Mind podcast episode 60. In this podcast we cover topics such as engineering, AI, neuroscience, life and other interesting topics and fascinating ideas to educate, inspire and engineer people's minds all around the world. I'm your host Yusuf, and for this episode of the podcast I'm very excited to welcome Sharon Zhou to my show. Sharon is an expert in deep generative models such as Generative Adversarial Networks, short GANs. She created and teaches the Generative Adversarial Networks course at Stanford and on Coursera with nearly 40k students enrolled in the latter. Sharon also has a penchant towards applying generative models and AI more broadly to social good. Some of her research is on AI for climate change and healthcare as well. She loves spending her time building generative models and thinking about how we can nurture them for good. In this very exciting podcast, we covered generative models, women in academia, transitioning from the industry to academia, pros and cons of GANs, misconceptions about deepfakes, working with Andrew Ng, and much more. For updates on upcoming podcasts, projects, and videos, make sure to follow me on Twitter as well as on Instagram. To join my weekly newsletter engineeredmind.sh, where I share exclusive content, visit yusuf.substack.com. And now, ladies and gentlemen, here's my podcast with Sharon Zhou. Hey Sharon, welcome to my podcast. I know that you're a very busy woman, so I appreciate you being on my show. Welcome, first of all.
Thank you so much.
So today we want to talk about generative models, your path as a PhD researcher, and also asking you some random questions. But of course, we want to get started with you giving us like a 1 minute or 2 minute bio of who's Sharon and what does she actually do?
Yes, so I'm Sharon. I'm a PhD student at Stanford, advised by Andrew Ng, and my focus has been on generative models, specifically on GANs, because I find them very fascinating. And so I teach the GANs Coursera course, where we have about 20,000 folks enrolled and rolling, as well as the Stanford GANs course at Stanford. And I run a research group and we work on GANs for good, so GANs for medicine and for climate change. Previously I was a product manager at Google and various startups before I started my PhD.
This is great. We will talk about this kind of distinction between being a product manager and working in research in a bit more detail during the podcast. What makes it so special that you work under Andrew?
Well, Andrew's a very special person. I'm not sure if I'm a special person. I really enjoy working with Andrew. He has been a very good advisor to me. And I think it took me a bit of time to all the people who are tuning in who are in their PhDs early on. It took me a bit of time to find the right fit for advisor, but I think he definitely is. And I really like chatting with him, not just about, technical stuff, but also about life advice.
But yeah, that's great. Also, to cover, if you're special, of course you're very special, because the way you teach, for example, in the Coursera course is very special in my opinion. And I think everyone who wants to take the course or learn more about GANs should definitely take the course. And I will, of course, put a link down in the description. And talking about special, you are also the first female PhD student under Andrew, if I'm not mistaken.
Yes, I am.
So this is great, right?
This is fantastic. Well, I was hoping there would be more women coming before me, but hopefully this will set a good precedent. Andrew, for the record, definitely works with a ton of women. His main focus is definitely on his amazing companies that he's started. And there are a ton of women there. So I know people were very concerned on the internet about the lack of female representation in his group. But I think it's because he's definitely eased off on the Stanford stuff. Of course, he's still here, but yeah.
Were you also motivated because you delve into the field of AI, for example, by women, for example, Fei-Fei Li, who is very famous?
Oh, Fei-Fei's amazing. Yes. I did kind of attend a lot of her group meetings when she was at Google, and I was there as well. And so that was fun. That was actually my first foray into the computer vision field when I was chatting with her. And she is amazing. She has paved the way and keeps growing. And yeah, I can't wait to see what more she does. I mean, she's working on the national cloud now, which is an initiative that is relevant nationally and domestically, for the whole country. And I think that'll really push research forward I actually see it as kind of an interesting way to essentially tax the different cloud providers and give it to academia to make deep learning a little bit more accessible to everyone.
Yeah,
I think that's
that makes complete sense. And what would you tell women who are a bit afraid to delve into the field, because it's kind of a man-dominated? It sounds a bit weird, but it's mostly dominated by men. What would you tell them if you want to delve into AI?
that there are good men and women in the field, and that even if you do, face something not so great, to find the right people and to really collaborate with them and really lean into those groups and work with those people. And they are there, or you could create your own thing, your own initiative, which is kind of what I did this year by creating my own little group of amazing students and just having a great time that way too.
This is great. Maybe we'll talk about that later on again to motivate women even more to jump into AI. But let's jump to generative models. And there is a famous quote by Richard Feynman who says, "What I cannot create, I do not understand." So this is kind of the basis of all the generative models. So basically having a lot of data, but creating even more data and understand how a machine generates these data and maybe even understands the data. For example, if we talk about explainable AI, which is an important part of this whole process. Can you explain for a complete newbie in the field of generative models, why do we even need it and why is it so important?
Yes. So in the field of machine learning, one way to think about different models is the distinction between discriminative and generative models. And discriminative models are ones that you're maybe very familiar with in terms of they can classify a cat from a dog, for example, and they can classify all different types of animals. So it's really trying to find the discriminating boundary or the difference, the distinguishing features of, let's say, a cat versus a dog. For a generative model, it's a different type of task that the model is going for. And so that model is trying to model all animals, for example. And it's trying to model, understanding how often do furry ears show up? How often do, like a floppy tongue show up in dogs, I suppose. And so like how often do all these features show up is what the generative model is trying to get at so that it can produce new ones, so that it can model this entire space. And of course, you might be wondering, wow, that must be a hard task. And yes, it is actually a much harder task than what the discriminative model can do. Because I can say, I can tell a cat from a dog pretty easily, but can I model all cats and dogs and tell you all the features and how often they occur? No, I don't think I can do that. So it is an impressive task. And I think in being able to model all of this and the features and perhaps even the probabilities of these features in some cases, generative models have become very useful for things like generating new samples that are useful for perhaps your data set is really small and you want to make it bigger. And so like generating new samples and maybe it's small because it's like we don't have that many samples of cancer, for example. And so we want to generate more of that so that our downstream models can then classify cancer easily. Mm-hmm. Or it's around anomaly detection. If we can model what is common, then we know what is anomalous. We know what is not common.
Yeah, that makes complete sense. For people who are not so familiar with AI and thinking, for example, if we take OpenAI and DeepMind creating the reinforcement learning agents for games, and someone might think, okay, why do we even do this? Or you talked about cats and dogs. I mean, for someone who is into the field, we know exactly why we do it. We want to understand how the machine thinks in a bit more detail. But can you explain what is the underlying motivation to study these generative models in a bit more depth?
Yeah, so the underlying motivation, I think, is to, if we can understand how often these features occur, and if we can better model an entire space, let's say, of human faces, then we can get a much better, then these models are much more powerful and I would say closer to AGI, artificial general intelligence, in terms of understanding how often things occur and what is real. What is realistic to us humans, and what characterizes a face entirely in its entirety, like all possible faces, for example. And I think this would also allow an agent to perhaps take on demeanors of a human. Of course, that's getting into deepfake land, and there's all sorts of issues with that. But it would enable a future, let's say, potential AGI to kind of interact with you as a human as well. And perhaps, I think some people actually find that extremely exciting. And I think there's also really cool work combining both images and text such that we can essentially enable much more creativity through simple natural language. And so if you look at OpenAI's DALL-E, a recent model that they put out, you can input any text and it's modeled it and understood that text sufficiently such that it can find images that correspond to it very well. And I think the canonical example in their blog post was the avocado chair.
Right.
Amazing chair that looks like an avocado that isn't found on the internet anywhere else, and it just made it. So that enables, future design and all sorts of things like that.
Mm-hmm. Yeah, it's very exciting. Also, when you talked about generative models and discriminative models, the most famous topic, I would say, especially for newbies who delve into the field, is what we call GANs, so Generative Adversarial Networks. If someone has no idea what this actually is, there's this famous example where one guy is trying to fake paints in such a good way that the discriminator is not able to distinguish between fake and a real painting anymore. But when it comes to a deeper mathematical level, how would you explain it on a deep mathematical level, how it actually works?
Yeah, so if we were to step one level deeper, so we first have the generator that is generating all sorts of fake examples or fake candidates, paintings perhaps, and then the discriminator is trying to detect whether something is real or fake, and it's given both real images and fake images. And so the discriminator basically has to look through these samples and take this test, deciding whether this sample is real or fake, and then it's told whether or not it was right or wrong. And during that process, that is just basically, you could just use BCE loss, binary cross entropy loss right there. And it's just a classification problem of cat to dog, but instead of cat to dog, it's real or fake. And so that's how the discriminator learns. And one component of what the discriminator learns in that BCE loss is on the reals, and one is on the fake example. And on the fake examples, that component is then given back to the generator, and the generator now knows what the discriminator guessed. And the generator is now thinking, okay, I know what you guessed. So I know that you thought this one was slightly more real, and I'm gonna do this now. And so basically uses that part of that equation, the BCE loss equation, on its own generated fake to use that in its back propagation. But the negative, the opposite. So they're adversarial because they are literally have nearly opposite loss functions.
Yeah, what is then the optimum? Can we, like in terms of topology, can we think about some kind of topology with just like a saddle point? So if you look from one plane, it would be like a parabola, like a upside down parabola. And if you look from the other side, it's like exactly the other way around. And if you look in the three-dimensional space, it's kind of a saddle point. And how do you make sure it stops training? What is like the criterion to make it stop training?
Oh, what $1 million question right there. Stop training. I think right now we don't have a really good mechanism to detect. And so right now it's really because as humans, we are the best almost judges of actually both realism in terms of fidelity as well as diversity to some extent. Because we are the judges, often it is actually just a human researcher looking at which checkpoint does the best. Because even if we look at the loss functions, they don't always tell us the entire picture. And typically, the longer you train your model, there will be a point where it starts getting worse or potentially mode collapses. There's basically this game between the two models can be very unstable. I would say that recent advances have made it much, much more stable, such that it's not as big of a problem. But even the most advanced models, at some point, you do see it kind of taper off a little. And I mean, discriminative models might be similar in that, at some point you just like overfit so hard to the training set, it's useless. So I know there's also work where it's like, if you overtrain, it actually gets past that point and then gets better. I don't know.
Yeah.
I don't know what's yeah. But I think that was only on like 2 or 3 layer neural networks. I'm sure that's improved a little bit now. I haven't looked at that in a year or two. So so I think like we're still working on, when do we finish checkpointing? Because that is where evaluation in generative models is just so much more challenging than discriminative models. Discriminative models, you can just hold out a test set and just see what your accuracy is on that, or a validation set. Excuse me, please have a validation and test set. And PSA on that. And see how you do on that validation set. And then decide, should I continue training? Should I stop training? But for generative models, it's much more challenging. And so a lot of my work has actually been on evaluation metrics, but there's still no perfect one. So if you're interested in this space, I encourage you to jump in.
That's great. Well, thank you for the explanation, Sharon. And also you mentioned a point which is very critical, I think, because you said that humans are the best discriminators in some sense, or like judges. This implies also that there's, like I have to pay attention to what I say now, that there's always bias inside what you're actually doing in the machine learning model, in some sense, right?
Even more so than probably a discriminative model. Well, I guess a discriminative model, you as a human decide kind of how to split the train val test splits. And even if it's random, maybe the entire data set is biased, so it's not really random. It's not the desirable randomness that you would want for evaluation. So I think like very much humans are so much part of the evaluation pipeline, even more so for generative models, even more explicitly, I would say. And so I think that's where bias could definitely seep in. And I think it's almost the most dangerous place to seep in, because evaluation is when you decide that you want to use a model, to actually deploy it in the real world. It's when you're thinking about safety, as a criteria. And it's when you're thinking about all sorts of things like that. So it's still a human making the decision at the end of the day.
Yeah. Also, when I talk about generative models, you posted a tweet today where you talked about trends in generative models. Yes, it's about efficiency, the latent space discovery, which is for free, as well as avoiding adversarial loss. I have to admit, I did not understand anything, and I saved all the papers to read at some point. Can you explain each point, maybe the trends in generative models and where we're heading to?
Yes, absolutely. So this was after kind of reading, I think, 10 to 20 papers with my group. From iClear this past year, and also I've been reading every conference. But after reading iClear, and this was like felt like the close of the year, I thought about, wow, there are some significant trends that I'm seeing in this field, and so one of them is definitely around efficiency, and I think that's super cool. Models are very heavy and therefore not as accessible, and a lot of the work that comes out are from OpenAI, DeepMind, NVIDIA. And so these are people who have essentially, from my perspective as a PhD student, they have infinite compute. I'm like, oh, huge GPUs. No, I'm kidding, it's not that bad. But they have essentially infinite compute. They have a lot more compute than I have access to. And so looking into work on efficiency is huge, where you don't lose much on the actual result in terms of fidelity. And so I think that's really powerful. And when I say efficiency, I mean there's work being done on reducing the number of parameters in these models. So that can include pruning. There's a nice piece of work around like GANs can win the lottery ticket too. So lottery ticket hypothesis, pruning, distilling a model, compressing that model. There's also work on fewer shot learning, so using less data for your model. And so you don't need hundreds of thousands of data points. Maybe you just need 1,000, maybe even less. And so that's really exciting because, we want to also be able to build these models for smaller data sets too. And then the last one I think I pointed out was around EBMs or energy-based models using tactics from VAEs. Also just generally, if we set back, just hybrid models such that we can get the best of both worlds in a sense. And I think there's more work on looking at that. Mm-hmm. And I think the second trend is, remind me what my second trend was.
Efficiency.
Oh, that was efficiency. What was my other trend?
We had the efficiency, latent space discovery for free.
Oh, latent space
Sorry.
For free, yeah. Sorry.
I have it written down. Sorry.
Yeah, you're cheating. I'm kidding. So latent space discovery for free. My God, this area is so fascinating because you have your generative model and you already trained it. You're like, I'm done. But you can actually discover all of these cool things in it. And I think an oral at AdClear and also a best paper at one of the big computer vision conferences this year really looked at how can we exploit 3D structure from a 2D model. So a model was trained on only 2D data, but now we have 3D structure. And I think from a lot of people who train GANs and generative models, we're not very surprised that you could do that, but it is cool to kind of formalize that and say, hey, like we can actually very much with your model, like already add lighting, change how you tilt your head, all of these things. We can do that now for free, like without doing much extra compute. And so for free could mean without much optimization afterwards. It could mean without supervision, so without any labels, so unsupervised. And just generally, I feel like latent discovery also is associated with training models that are more disentangled. And so disentanglement has also been a pretty big theme that's been gaining speed, because I think in terms of fidelity, people have already felt like, we've reached a really good point. These things are realistic. So we've almost, moving towards something else in research, which is, disentanglement is useful too for controlling that latent space or for understanding or interpreting that latent space a little bit better. And then the last theme is around avoiding adversarial loss, which I mentioned before is the premise behind GANs and how they are people argue it's slightly unstable. And I think there are a lot of ways to mitigate it. But that aside, it isn't able to, let's say, explicitly model density, for example. And so some people want other properties of generative models. And so as a result, there's been a push for score-based generative models. And then I recently saw a full paper on Wasserson 2 generative models. And yeah, so basically just new types of generative models are always kind of burgeoning on the surface as well.
Good. And I will put, of course, the link to your tweet as well as in the description as well, to make sure people can check it out and see all the papers and links you posted, which is really great. Also, you talked a little bit about risks and benefits of GANs, and also we want to cover misconceptions about GANs, because I have to admit, when I delved into the field of GANs, I was like, okay, this is deepfake. And everyone is thinking, okay, deepfake must be a GAN. And this is, I think, one of the biggest misconceptions, right?
Correct, yes. So a deepfake is not always a GAN. In fact, I've fact-checked a lot of people. So I've read a lot of articles and then talked to people behind the scenes. And a lot of them are not GANs that people are using, even if they do look like GAN outputs. So they can range from pure graphics, so using graphics, no neural methods at all, a combination of the two, or using a different generative model type, often a VAE I've seen as pretty common. And so I think that is one common misconception, that it's always a GAN. I will say that the acronym GAN with the word adversarial really doesn't help. And I think it's easier to say both GAN than VAE, like word-wise, and also the separate words, even if you don't think of it as an acronym. Generative Adversarial Network seems like a more accessible thing than variational autoencoder. So I would say the biggest contender to deepfakes is VAEs, but I think all generative models are capable of doing this, right? And to varying degrees, of course, they're all competing on making something high fidelity or highly real. And as a result, that is one of the very, very detrimental use cases of these models.
This is great. Thank you so much, Sharon. Do you want to talk about the pros and cons of GANs? What would you say? The top 3, maybe.
Okay, cool. So definitely the biggest pro that you get from GANs is the realism you get from it. So it helps with realism even when you're not necessarily trying to make the generative model, the GAN part, the main thing. Even if it's playing a supporting actor role, it is actually it can help another model be more realistic in some way. Like that adversarial loss component with this discriminator, that can help a lot of different training schemes. And so I think one big pro is around realism. This is the discriminator. Your discriminator is essentially learning a function for realism. It's trying to be a human to decide what's real or fake. Mm-hmm. And that's really hard because we can't encode that mathematically, right? So we want to just learn it. And so that's essentially what's happening. On the other side, in terms of a major con is we don't get explicit density estimates. And what I mean by that is that we don't actually model the probability distribution of all different features as a probability distribution. And this can be very useful because other models are capable of doing this. And this can be very useful for, you can imagine, just understanding how often things occur and also understanding when uncommon things occur. And I mentioned anomaly detection previously. And so that's exactly what, that is one possible use case of density estimation. Yeah, and I would say that those are like the major pro-con kind of arguments for and against. There's definitely the instability argument of it's not super stable, but I would say that's been mitigated in the past few years. It's been like, I'm like, this is pretty stable. And another pro is it's pretty fast relative to some other models for both training and inference, like relative to like the score-based models coming out now. I would say to some models, it might be around the same thing, but it is decently fast when it comes to inference. Yeah.
Great. Where would you put explainable AI, so XAI, in this whole framework? How important is it, and where do you see it heading to?
Oh, explainable AI. Wow, explainable AI. I just read that paper from iClear that kind of said, we're not sure that the grad cams we're using, the gradient class activation maps that we're using are the best way for explainable AI. I thought that was like a really big statement. They are good. They're just not, they're not great. And so I think the world of explainable AI, I actually don't see it entirely using GANs that much. I would say that if we were to use generative models, it would probably be around, a combination of, hey, we're using this for some kind of visualization such that a human could understand using this generative model. But we would have to be very careful because these generative models are hallucinating things. And it's not always, exactly representing something. For example, let's say we have a really blurry image and we want to do super resolution on it such that we as humans can see what's going on. When that happens, it actually is hallucinating things. So it's not actually what was in the picture. It is just what was most likely in the picture. Mm-hmm. So that is what's happening. And so I think when people do that, they're like, Sharon, guess what? I'm going to do super resolution and then I'm going to train my other model because it'll be better because those images are better. And I'm like, those images are actually not better. You actually added noise, but like that noise is based on, what's likely to be there. So it doesn't always mean that'll be better downstream because in a way you're not adding information. You're just, you're not exactly adding information. But I will say that for explainable AI, my work in medicine does kind of look into this and around, I also care about human-computer interaction and how we design usable interfaces. And so I think explainable AI very much fits in there in terms of how do we talk to doctors? How do we communicate these outputs of a model to a doctor? How do they validate that this is realistic or good, or this model can be even useful? And we talk a lot about not replacing doctors, but how do we even augment them if we don't have good ways of helping them? If we're only focused on model accuracy or AUROC, then how are we going to actually say, hey, like this is actually a good collaborator for you, doctor? So I think I've been thinking about that a bit and how interfaces can both improve or hinder the ability for an AI to collaborate with a doctor.
Yeah, I really like that you made the statement to actually augment the human being and not actually substitute the human being.
Yeah.
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 We also want to talk about you or people in general having a non-technical background and jumping into AI. What would you generally recommend them? Maybe top 3 tips, or just maybe talk about your own experience, because you said in the beginning that you were in a product development position and then you switched more into the AI/research field. How was it for you?
Yes, I did. And if we go even back further, my undergrad, I studied classics first, which is Latin and ancient Greek. And then I added computer science, and so I did a double major. But I did find computer science pretty late relative to, people who started coding when they were 6. So my biggest recommendation is to figure out how you learn best. 1, and 2, find something that you're fascinated by, and to be patient with that, and to explore as much as you need to find something that you're actually very curious about and that makes you enthusiastic. I don't want to say passion, because I think passion has a lot of different connotations, but I think just excited. You're like, wow, that's cool. And I found that with generative models, because I was like, I can tell cats from dogs. I'm not impressed with this classifier, but this generative model can do way more than me, and I'm very impressed with it. And so that's what got me with that. And I started just working on the side on those projects. I was working on other stuff before, but yeah. So being willing to open doors and to explore, I think, is a huge one. And knowing how you learn best is huge, I think, as well. Especially if you learn differently from other people. And so I learned a lot just from on the web on my own. I notoriously don't attend to lecture. I'm very bad. I hope my students are not listening to this. I'm kidding. Lecture is not required. Attendance is not required in any of my classes. Because I feel like a hypocrite if I force that. So I definitely skipped school in both high school and college, let alone grad school. So you can probably imagine I'm not very into the traditional education format. And so I would recommend, but figure out how you learn best, because once you figure that out, then you succeed. On paper, it looks like I very much love the traditional educational system because I went to my Harvard as undergrad and now Stanford for PhD. But I don't. That's not how I learn best. But figuring it out and just really being like, I'm going to do it that way, I think it's the way to go.
Mm-hmm. Do you also think it is important to learn how to learn, especially in academia?
Yes, definitely. Well, figuring out, everything around both time management, energy management, figuring out, what gets you really excited. Are you most productive the 3 weeks before the deadline? If so, how can you make sure you're in the right position to do that? And I think all of that is really, really important. Mm-hmm. And I realized I could be both very creative and very focused, but I have kind of 2 different realms, one where I'm very creative and often very extroverted, and another where I'm very introverted and very focused on getting something done as fast as possible. And so realizing I want to modulate between these 2, and sometimes I need more, and sometimes I need more of one versus more of the other, and allowing myself to do that, or also setting up my environment such that I can do that is important.
This is a good hint, because of course we talk about all these kind of theoretical topics during the podcast, but I think people want to know also more about you as a researcher and you as a person. How do you manage time in general and energy? How do you approach this?
Yes, so I know that I do my best work and I feel happiest when I talk to certain people and collaborate with certain people, as well as when I have focused time. And so I make sure that I have a certain amount of focused time every single week. And one thing that I care a lot about is also taking risks. And so in my calendar, I used to have this calendar that does this, but now it's more, I think, just a habit now. But I would have one fearless thing as something in my calendar every single day. And that would remind me to do something fearless every single day. And that could be something as small as a cold call, like a cold email to someone. or something very big. Like I've definitely bought tickets to like London once to just visit a friend and just do it. Like do something fearless that feels uncomfortable. And then over time, it just becomes so comfortable and it's fine. Like, oh, cool, okay, whatever.
Mm-hmm. Is podcast on your list of things which are uncomfortable?
No, actually, this may or may not be one of 3 podcasts I'm going to do today. Today's my podcast day.
No, okay, got it. Also, general advice for people. There's one nice video from Andrew where he talks about how to read paper. How do you approach this? Do you follow his advice, or how do you approach paper in general? Because there's so many papers coming out, and especially people who are starting the journey or taking maybe your course about GANs who are excited about this field. They have no idea how to compete against these big researchers, these people who seem to be so smart. How would you approach this, or how would you encourage people?
Yeah, so this goes back to how you learn best. But one approach that's worked for me has been if I really want to delve into a field, I start reading a paper, and if I don't understand a single word, fine, doesn't matter. I take the next seemingly relevant citation, and I keep going backwards until I basically hit a Wikipedia article that I understand. Basically I hit something that is so basic that I can be like, I understand this in its entirety. And so let's start popping the stack, right? Because like you have this massive stack, so start popping all the way until you get to the very bottom of that stack, and you're like, I can read this paper now, but it's taking me all of this massive tree. Actually, it's probably not a stack. It's tree to get there, and I think that's fine. Like just find all those places where you are finally comfortable and come back. And maybe where you're finally comfortable is like the 1950s of work, and that's fine. Like just start there. Like that's where I was. I was like, I'm pretty sure Aristotle wrote this. It's fine. And you just do that, and then as you build those building blocks, you can work your way up. I think another hack is definitely to talk to people, but I know that can be challenging as well. I have been very fortunate to have certain people that I've talked to who are very helpful in that. But I would say actually the majority of a lot of what I've done has been also individual. So I wouldn't discount just like focusing and realizing there's so many resources for you out there, including very basic things like Wikipedia and Wolfram Alpha. Like these things will have nice resources, and you can play with visualizations easily. And so, yeah, that would be my recommendation. And be willing to spend, 12 hours for several days doing that until you understand. And like as exercise, I would be like, I'm going to go on a 2-hour walk where I am also reading paper. Like that was probably me in super intense mode of making sure I understand this field.
Mm-hmm. I think also it's not a good indicator maybe of how many things you understand and so on, but how many papers do you read on average per week?
I'm very bursty. So I have weeks where I have read like 100 papers. I definitely have kept track and tried to read like a ton before. And then weeks where I don't really read that many at all. And I just basically skim some abstracts, if anything. I might be really heads down. So I think I'm really bursty, but that's just me, because I feel like when I read in a certain area, I want to read several papers to really understand what's going on, not just one. Like I think if it was a paper a week, that wouldn't quite work for me in terms of understanding the scope of things and consolidating.
Okay. Does it also support the understanding a bit more, because you have kind of a network of papers which relate to each other, and then you would understand it a bit more?
Yes, exactly. Because honestly, most papers are pretty incremental. And so they're just like very small differences from each other. And just once you get one of them, like the others should be pretty straightforward, and just pack it all together. You're like, oh, that's where this is situated in relation to this other thing.
Got it. Okay. So now research versus industry. Why did you decide for going into academia and not stay in the industry anymore?
Oh, I've not said I'm going into academia. I have done a PhD in a PhD program, but I don't want to stay in academia. Is my main intuition. Yeah, I do feel like my theory of change in the world is to see it is through building organizations. And I think that is the most change I've seen in the world. I think academia and research is beautiful, but I don't see that as impactful as much as building out a strong organization and moving towards a goal.
That makes absolute sense. Yeah, sorry, I got that wrong. What is the plan for you in the What is the plan for you in the coming years in terms of maybe founding your own company? Can you leak anything regarding that?
I can surely leak everything. So I am brainstorming different ideas right now and validating certain hypotheses I have, and kind of chatting with people I like and just jamming on ideas like that. And I think that is what I'm going to do until I essentially graduate, and maybe for a few months after I graduate, and then hopefully start something that I think that I'd be excited about and that I think is impactful.
This is awesome. Yeah, I love it. If there's someone who wants to delve into the field, let's say, who has a non-CS background, technical background, and he wants to jump into programming, to work with GANs, generative models in general, because you are so enthusiastic about it, I think it's very infectious. And if people are very motivated and want to take your course, what would you recommend them to do if they have no idea where to start and feel a bit overwhelmed? I mean, you gave some tips during the podcast, but what would be your advice, like the one advice you would give them?
I'm going to plug my friend. If you're completely non-technical, I'm going to plug my friend's thing because I really love it. And it's artbreeder.com. And it's looking at generative models as kind of art, but also as genes. So you can change like a generated face, like you can make me younger or older by it's a gene that you can just ogle. And so just starting to get interested, starting to realize like, oh, this is some weird thing over here, another weird thing over there. You can create your own genes, for example, like all this cool stuff. And so playing with the models first, because they are out there without knowing anything technical, is fine. And to start to build that out is totally fine. And actually, he's told me that people have built like careers on top of his website. So you can also never touch the technical and build it off of his website. But you can, and then maybe that'll make you more interested in maybe learning some of the basics, starting from linear algebra if you're not really familiar with that. The basic math principles, basic deep learning from Andrew's specialization on Coursera, and then the GANs course, of course. And of course, like a lot of these resources are available, and I'm pretty sure there's like a free trial, so you can always like go in and like check things out and be like, no, I need to come back to this later. And so that's totally fine too.
Great. So before we wrap things up, Sharon, maybe you want to add some more points at the end and some recommendations. I have something prepared which I know it's a bad name, it's called Question Rampage.
Oh yeah, this is what I signed up for.
And it's 10 questions I have prepared, and optimally you give like a one word or one sentence answer. So let's jump straight into it. Question number 1 would be, what excites you most about AI?
Generative models. It's not exciting. That's so predictable.
you can change your answer if you want. You can choose.
GPT-3 could have predicted my answer. Okay, keep going.
Second question, most fascinating concept for you in AI?
I don't want to say generative models, but it's so true.
Okay, we know the answers already.
Dude, I mode collapsed. Like, what's happening?
Okay, let's just say generative models.
Okay, let's keep going. I'll get better, I promise. I will remove myself from this local optimum.
Okay, let's see. Third question. Okay, now you can't answer generative models anymore. Let's see for this. So, third question would be, who would you like to spend one day with? Don't say generative models now.
I'm kidding. It'd be like the Mona Lisa, but again, Mona Lisa.
Oh no.
No, sorry, that's not the right answer. Okay, so I definitely really appreciate memes. So it would maybe be the meme lord Elon Musk. Or Actually, his girlfriend Grimes, I think, is super cool too. So maybe her.
Actually, I would have given the same answer. That's fascinating.
Yeah.
Next question. Who is your biggest inspiration?
My biggest inspiration actually comes from Louis von Ahn, from way back when in college. He made CAPTCHA, reCAPTCHA, and Duolingo. And he really is good at incentive alignment. And I just respect that in so many ways. Yeah.
Mm-hmm. What country will contribute the most to AI in the future?
Oh man, it's a battle between US and China, I feel like. I feel like I want it to be the US, but I feel like it's possible that it'll be China, due to its lack of there.
Yeah. Okay, the next question would be, what's the one time management tip you would give to others?
Accountability, actually. So basically setting a time where you'll meet with someone to chat about something. And so you need to get that something done by the time you meet with them. Mm-hmm. That's my favorite.
Great. Favorite operating system?
Oh, man. Oh, I very much respect OS X, Mac. But it's also limited, so I don't know. Yeah, I would have to say that.
Would have
predictable again.
Yeah, would have said the same thing. I mean, it's.
I know. It's just Linux gives me too many issues, so.
That's right. Favorite framework for AI research?
PyTorch.
Nice. One thing you cannot live without?
Ooh. I would have said phone back then, but now I've weaned off my phone. Oh, probably tea.
I like that answer. That's good. And
I looked at my cup over here. I was like, that caffeine drink is essential for my life.
most favorite tea, by the way. What's your most favorite tea?
Oh, it's actually pu'er tea. I don't know if you've had it before.
Probably. I have so many teas in the kitchen. I have to check it.
Yeah.
And we have the last question, which is accomplishment you are most proud of.
Ooh. What am I most proud of?
It's too many things, right?
To you, actually. Okay. Like, oh, like that. Is that even cool anymore? No, I'm kidding. Probably I think of recent times, one of the things I'm most proud of is definitely the GANs Coursera course, not just for the content that you see, but also the stuff that you don't see, which were all the takes that we took for everything, and how, honestly, in the beginning, I didn't think it would even go out. So I was really just teaching to my sister. So I was really teaching one-on-one with her. And so I think that made it a really special experience too. Yeah,
I can relate, because people really don't or only see the tip of the iceberg, because I'm also creating a Coursera course, but for engineering kind of topic. And if you see like what's behind the scenes, how many takes you have to take and how difficult it actually is, this is crazy.
Yeah, it's absolutely insane. My first take for some of the videos, I was doing it in a closet for good sound. And I had to turn off my air conditioning because it was too loud. And it was in the summer during the heat wave in Palo Alto. And I was, according to other people, I sounded like I was dying and very miserable and hated the course. I was like, okay, thanks guys. I mean, I was dying, and I came out with like a raging headache for several days because I was super dehydrated.
Do we see it in the course though? Do we see it in the course that you are sweating or like?
Never. We recorded all of those. Those were so funny. funny. I was like, wow, I've never sounded like I was dying in my life.
Yeah, but I think when people listen to this, I think they would really appreciate how much work actually goes into a course. It's crazy. I can't imagine how much takes Andrew took, like in the beginning when he started the ML course, for example. That must have been crazy.
Yeah, it's insane. It is insane. And all the people who helped it, like it was almost like a production, like a movie, like a mini movie that was going on. Because you have people in production. You have like all of these people who are helping out on all these components. It's like a massive, massive thing. And like testing, you go through rounds and rounds of testing as well. And it was just like, oh no, we had to change all these things. And so it was a huge affair, but I think it also, I feel like I learned a ton around, how do I keep thinking about how, like some of those videos, especially the ones on, I think, Wasserson GAN, gradient penalty, one Lipschitz continuity, those videos took me a very long time to build out because there's no material that's accessible out there on the web. So I had to think like, how am I going to make this accessible? This is all these facts are buried in papers. How am I going to make this so that this person can understand it? There's like a lot of that going on. So a lot of time was sunk into making something understandable.
It's crazy, yeah. Did you create a script for it, or did you just talk into the camera?
The first videos were scripted, and then I was just like, I don't want the script. I was like, I'm just taught. It's like some of the script was like, sometimes the script was wrong. So I was like, I'm just not going to use a script anymore. And there were definitely testers who said, I can kind of tell you're scripted. So I was like, I'm going to just stop being scripted now. It's going to go crazy. But then there's also the other side of this people sound better when you're scripted too, because like you don't have more ums and stuff. So I don't know. There's like you need to find a good sweet spot for that.
Mm-hmm. Yeah. To wrap things up, anything else you would like to tell the audience, Sharon? Anything where they can find you, how they can reach out to you, or anything else that you would like to tell the audience?
You can find me on my website. I'm sorry, it's kind of a bad website. It's like, I'm very old. It's like when I first learned how to code and I still kept it like that. But yeah, feel free to reach out to me for advice on things. If you have outputs from your GANs, I'd love to see them. You can straight up just send those to me. Memes, I also welcome. Basically all of that. Fun content is always welcome.
You shouldn't have said that. Now I will tag you in a meme on Twitter.
Dude, I love that though. That is what I live for.
Then I'll create one for you and then I'll post it on Twitter.
Yes.
Okay, and I'll also, of course, we'll put the link down to your Twitter profile in the description because I think you post very useful things, especially when it comes to generative models. I think this is like the 500th time we say generative models at this podcast, but yeah, this is how things go. And I have to check out the papers, and especially the tweet from today, I will post it also in the description. With that being said, Sharon, I thank you so much for your time, and hopefully there will be, let's see, a second part maybe about medicine and climate change and how we can use AI for that.
Awesome. Thank you so much for having me.
Sure.